Now let us get into reliability test much more deeper level so we can understand how it works. Okay, and how to report this reliability also. Now just to make us to understand reliability much better way, this is a data set which contains about different items like SUP for support of student in their education, ADV stand for advising, TUT stand for tutorial, and VAL stand for perceived value, students perceived, and loyalty stand for how much they are loyal to the institutions, etc. And there are some kind of like a demographic variable like gender, scholarship, job, etc. etc. So let us take one thing for loyalty. Let's run the reliability for loyalty. So as we are aware of analyze, scale, reliability, and select all the loyalty variable items for loyalty. You can see, so these all items, and there is one more item is alpha by default, and say OK. So now the result shows Cronbach alpha is 0.268, number of item is 5. As we are aware of, Cronbach alpha is minimum required is 0.7. Value what we got is much lesser than threshold value. So it shows there is some concern in the data. Some items are not cooperating. So how to identify which items bring down the score? For that, we'll just go back once again to do a reliability test, analyze, scale, reliability. This time we'll go choose button called statistics. In statistics, below descriptive you can choose scale and scale if item deleted. So you can choose both the things. The purpose of choosing this one here is to figure out which items bringing down the score of Cronbach alpha. Continue and say OK. So here we are getting same old Cronbach alpha and item to total statistics. Here we have to focus on the third column, that is called corrected item total correlation. Ideally, all these items should get a positive. First of all, it should get a positive. Second thing, it should be more than 0.3. But we can see there is a one items like loyalty dot Asha, which is getting negative. So this need a reverse score actually, need a reverse scaling. So reverse scaling means all these items are positive connotation. This is negative connotation. So it need a reverse scaling. So normally when you do reverse scaling, first we should understand the maximum rating scale and add one on top of that. And you can do this total score minus actual score. That is how we do reverse scaling. Or you can go by recoding. If it is a 1 means convert into 10. If it is 10 means convert into 1. So either way you can do it. So as we are aware of, this score is here in this score. Let us check the score. How do you check the score means? Let us go to mean score, analyze, scale, reliability. In terms of statistics, we can say mean. Say OK. So this shows the score is it is going like it's a 7-point scale because score is go beyond maximum is 6.6. So it was understood it is a 7-point scale. So when 7 is a maximum rating scale, add 1 on top of that, so it became 8. And 8 minus actual raw score, then it will become reversing the score. So how to do that? Let us go to a transform, and we should know which all item has to be reversed. So for us, the item has to be reversed is loy.asha. So transform, compute variable. So we are creating a new item called loy. And here we have to take 8. Why 8 means the maximum score is 7 plus 1 8 minus raw score. The raw score is stored in the old variable by name called loy.asha. Then say OK. So this will generate a new item called loy asha. So if you see this old and new item, if we compare with old and new items, this is an old item, this is a new reversed score item. Wherever 1 becomes 7, 7 become 1, and 4 become, because the 4 is a midpoint, so it doesn't change. 2 becomes 6. So this is the old items. After reversing, we get this output. So now we have to do Cronbach alpha once again by using the reversed item rather than the old item. So go to reliability analysis again and remove this old item and select the new item called Lloyd.asha1 and say OK. And this time we don't want all these things. You can say continue and say OK. So now surprisingly now we got a good output. You can see Cronbach alpha is 0.855. It's a standard is 0.8%, but normally we'll take a Cronbach alpha and 5 items. So this is how we have to do a reliability test. Before, when you're doing reliability test, ensure that it should be more than 0.7. If it is less than 0.7, we have to check item wise where is the problem. Once you identify it need a reverse scoring, then just go to transform and follow the method what we did it. Once we reversed it, again we have to check whether the concern is taken care. Yes, in this case, earlier it was a 0.25. As we are aware of, it was 0.25, 0.268. Once we reversed it, the Cronbach alpha become now 0.855, which is more than threshold value. So this indicating how to do Cronbach alpha. If there is a reverse item, how to do reverse item. So I hope we are getting understanding on how to do this Cronbach alpha. And beside this Cronbach alpha, there is other alpha also there. For instance, we just go to reliability analysis. You can see model is alpha by default. If you want to go with the split off test, you can go with the split off test and say OK. Now split off test, it will take a total number of items into two parts and it will run for each part separately alpha. Okay, so you can see this part 1 it has got 0.83 and part 2 it got something 1. Normally, one thing with this split off test is most of the times now literature strongly recommend a Cronbach alpha is the most required alpha test compared to any other test like a split off test or test retest or parallel form test. So checking Cronbach alpha is a more than sufficient to assess the reliability test. So I hope we understand, we learned two things. One is how to do a EFA technique and second thing is how to do a Cronbach alpha test.